Hello everyone. A while back I had a request on making a jetpack tutorial with a fuel bar. So why don't we go ahead and do that right now. I will split this tutorial in two parts. In the first part I will do the basic jetpack functionality, and in the second part I will add the fuel bar and add a fuel system. So let's get started. Let's drop into Unity, and here I have already imported a player script and a ground. I mean a player sprite and a ground. And the ground just have a box collider. And I will drag our player into the scene. And I will give him a collider as well. Let's make it a capsule collider and a rigid body. Alright, we can call him player. Let's go ahead and create a player controller script then. Player controller script. Alright, let's remove everything and let's start really simple and make him only move horizontally. So we need a variable, serialize field, private float move speed. Can set it to 3 as default, and then we can do the update method, and we also need a reference to the rigid body, so we can grab it right away. Private rigid body is, and then in the awake method grab the reference rigid body, get component body, like so. And then we also need a variable for the player input, so private float move input. Okay, in the update method we can get the move input. We set it to input.getAxis horizontal. Great. And then, since we will move him using physics engine, let's do the actual movement in the fixed update method. Fixed update. Rigid body dot velocity. Oh, we called it rigid body velocity. Let's set it to new vector 2. Then we only want to move him in the x direction horizontally, so we set the x value to move input times move speed, and then the y component should be what we are having at the moment, velocity.y. Alright, great. If everything works as intended, he should be able to move left and right now. Oh, we didn't attach the script to the player. Let's do that first. Now. Okay, yes, he does, but we forgot to constrain the rotation. Let's go to the player and freeze the Z rotation and try it again. Alright, it works better now. Let's increase the move speed a bit. 6. Great. Let's jump right into it then. Let's make the jetpack. Or let's make him jetpack. So make a new variable, private float jetpack force equal to 3 to begin with. It's a standard number for me. And then let's create a second variable to see if he's flying. Private float, no, boolean is flying equals to false to begin with. And in the input, let's check for the left mouse button. So is flying equal input dot get button, and it's called fire1. It's all right. So now in the fixed update, we can make him fly by checking for if is flying is equal to true. Then we will add a force to the rigid body. Rigid body dot add force, new vector 2. No, let's vector 2 dot up. So in the upward direction times the jetpack force. All right, let's see if this works. I'm pressing the left mouse button, nothing happens. I'm guessing we need more of a force. Yep. Okay, we can see that it worked, but we need to fine-tune stuff to make it feel and look better. Let's crank the gravity scale up a bit, put it to 6. Set the jetpack force to maybe 120. Yeah, this feels a lot better now. You can see if I'm holding the mouse button, he goes up flying, and if I release, he falls down again. Great. We can also see that when I'm moving pressing the directional keys, he's moving left and right without rotating or anything. Perhaps this is the way you want your game to be, fine, but I would like him to, instead of moving horizontally like this, I would like him to rotate and using that force to move him horizontally. So let's fix that. To fix this, we first need to find out if he's grounded or not. So we need to attach an empty game object on him, determining the ground position. Let's keep it in the center for now. In the code, let's make a few more variables. So to determine if he's grounded, we will be using an overlap box. So for that, we will need 2 variables for the size of the box. So float box length and equally the same for the height, box height. Then we also need a reference to the ground position. I will transform ground position. And finally, we need a layer mask so that the overlap box only considers the ground layer and not all the layers. Field private layer mask ground layer. Alright, let's go back to Unity. You can see that the ground is already on a layer named ground. So you can start by setting that. So set the layer mask to ground. Drag the ground position into a transform. Then to make this positioning of the ground position a bit simpler, now it's really hard to guess where the ground will be, we will be using gizmos. I just made a tutorial on this, so you can check it out if you want. So create an onDrawGizmos method, and in here let's give our gizmo a color. Color equal to color dot green. And the gizmo we will be drawing is a wired cube because it fits the shape of the box. So gizmos dot draw wire cube. And then we need a center. The center will be the ground position. and the size will be new vector2 box length for the width and box height for the height, like so. Yeah, ground position dot position. So now we can go back inside of Unity, and if we mark the player and increase the box length, you can see that a second box appeared here. This will be determining where what area under us that we consider ground if we are touching. Now it's a lot simpler to move this around and see what we are actually considering ground. Set it somewhere in the middle of the legs, decrease the size, something like this, decrease the height, and make sure that the overlap box is outside of his original collider, otherwise we will never touch the ground. So like this, when this box is touching the ground, we will consider ourselves grounded. So let's create an isGrounded variable. Private collider 2D. We will be using the overlap box non-allocation for this, and therefore we need an array of colliders instead. isGrounded equal to new collider, but we only need it to be of size 1. Only need the first element. Great. The first thing we will be doing in the fixed update now is emptying or nullifying the isGrounded variable. isGrounded 0 at position 0 equal to null. Then we'll do physics 2D dot overlap box non-alloc, and here we will first need a center point. So our center point, everything here in this should be the same as in this. So the center point is the ground position dot position. The size is a new vector2 box length box height. The rotation angle, we can set it to 0. And then we will not be using this constructor. We will be using, or overload, we will be using this one. So now we will need some place for the results. So the results should be in the isGrounded variable. And finally, the layer mask is the ground layer. Great. And now we can do if isGrounded 0. Only if we are grounded will we move him in the left and right direction. Okay, let's see if this works. I can move him, and then if I'm flying, I cannot no longer move him in the left and right direction. Perfect. But we can see if I had a movement before flying, he will keep on moving in that direction because of the momentum. And this is, at least not for me, desirable, but it's very easily fixed. We do that by adding a linear drag. Can try and set this to 1 to begin with. So now if I have a movement and fly, we can see that he's slowly slowing down. Let's put it up a bit to 2. And he's getting to a stop much faster. And this feels a bit better, I think. So I will keep it like this. Make sure to change it because we changed it in play mode. So now when we have removed the possibility of moving horizontally, we need to make him able to rotate instead. So let's create another variable. Serialize field, private float rotation speed, set it to 3 as well. Alright, everything we need to do now is add the rotational code in fixed update. But before that, we should change this condition to be if we are grounded or we are not flying. And then else if we are flying, then we should, instead of this, change our rotation by creating a rotational vector. It's a vector 3. Rotation equal to new vector 3. We don't want to rotate in the x or y direction, so x and y should be set to 0, and only in the z angle, around the z axis. So minus move input, because rotations are clockwise and we want this to be counterclockwise, times rotation speed. And using this rotational vector, we can set our rotation to be transform.rotate rotation. And also remember that we constrained our rotation in the z-axis, so we need to change that. So when we are grounded and not flying, we should set the constraint to true. Rigid body.freeze rotation equal to true. And likewise, when we're flying, we should set it to false instead. Great, let's go back and test it. Now press play. You can see that he can still move left and right. And if we fly, we can see that he's rotating instead. We can also see that he's moving left and right, which is probably because instead of or here we should have put and. Let's put and go back. Now he's not moving left and right, but we can see that he's rotating, and that's exactly what we want. But he's not flying in the direction that he's rotated to. We need to fix that, and that's very simple. Inside the code, we can start by moving this line inside of this, and here in the add force, add the our current rotation. So we can remove this. Oh, we need to put this first, otherwise it won't work. So our current rotation times vector up times the jetpack force. Now let's see what happens. Great. See, he's rocketing in the direction that he's rotated to. I think the rotation is a bit slow, so we set it to 5 and try again. And yeah, this feels a lot better now. I think I will keep it like this for now. Before going further, I want to fix something. I would like him to slowly rotate back to his original rotation when we are not manually rotating him. So to do that, we need another variable. Serialize field, private float, normalize rotation speed, set it to 3 as well. And then here, when we are flying, we should use transform.rotation equal to quaternion.lerp, so which will mean that we are slowly rotating to a point that we define. Use our transform.rotation. We want to rotate to quaternion time.identity, and we want to do it time.delta time times normalize rotation speed. Notice that I'm using delta time here. You could also use fixed delta time, but as far as I have understood, when using delta time inside of fixed update, it gets translated to fixed delta time automatically anyway, so it doesn't really matter. Alright, let's see if this works. Let's put this before the add force. Back and try. You can now see that when I'm releasing the rotational button, he slowly goes back to pointing upwards. This makes controlling him a bit simpler, so I like it quite a lot, so I will keep it. Alright, should we get the particles going so that we actually know that he has activated the jetpack perhaps? I have already created a particle effect. It's not very nice, and I imagine you can do a lot better, but for the sake of this tutorial it will do. You can see if it's oriented like it should. Go to shape, we can see that it's pointing upwards. We want it to point in the same direction that his backpack is, jetpack, so we rotate it around the y-axis in about 175. So it's not 180 degrees because, yes, you can see this isn't pointing directly downwards, but about 175 should do. Then we child it to the player. Then we can move it to where we think the nozzle should be. Let's see in the game mode, and it looks good enough. Let's keep it like that. Now go back to the script and let's add a field, a variable for the particle effect. Realize field, private particle system, particle, jetpack particle, let's call it. So inside of here, we need to make it a bit differently. We want to activate the jetpack particle when we have pressed the left mouse trigger, the fire button, and we want to deactivate it when we let go of the fire button. So in the update, we'll check for the input. If input.get button down this time, again fire 1, then we will activate jetpack particle by doing so, and then else if input.get button down up this time, when we let go of the fire 1 button, we will stop the jetpack particle. Stop. Okay, let's see if this works. Let's drag the jetpack particle to the jetpack particle. So now I can see that it's oriented correctly and everything works as it should. Perfect. Alright, great. This concludes part 1. In the second part we will implement the fuel system. See you then. Bye bye.